Lately, college parties never produce sexy European girls that drink heavily, even though you look. Now, I'm not talking about my early college days. I'm talking, of course, of the lanthanides on the periodic table of elements. And that right there is a mnemonic which I use to remember them. So these lanthanides, they're also known as rare earth elements and are used in many modern day electrical applications. So why should we care about these rare earth elements? Well, how many of you have a smartphone? Pretty much everyone does. I have one as well. Did you know that there are 8 of these rare earth elements that are necessary in the construction of your phone, in everything from the touchscreen to the battery? Now, as the name would indicate, these elements are not found in great abundance here on Earth's surface. And the mining procedures necessary to obtain them are becoming increasingly more expensive as their supply is depleted. Now, this scenario is not exclusive to all rare earth elements. All resources on Earth, as you know, are in limited supply. In fact, a recent United Nations study on resource depletion said that in the last 30 years, natural resources per capita has declined by as much as 20% here in the United States. Now, as the demand for these resources increases with the advancement of new technologies and the increase in its use, the price of them skyrockets, which leads to your $700 iPhone. So let's talk about a specific group of resources. The group categorized as the technology metals, which includes the rare earth elements that we just talked about, as well as heavy metals such as platinum and cobalt, are especially important resources as they are used in everything from flat-screen TVs to advanced communication satellites. Unfortunately, these metals are becoming exceedingly rare, which has resulted in the cost of them doubling every year. So where do these technology metals come from, and why are they so rare? Well, there are a few reasons. The first is that many of these critical metals were deposited by meteor impacts on the Earth's crust during its formation. The second requires just a brief explanation in planetary formation. Now, when planets are formed, denser materials, such as these technology metals we've been talking about, are pulled towards the center by gravity. Now, this phenomenon is not exclusive to Earth. This is true for every planet in the known universe. Fortunately, not every planet is as lucky as Earth. Some planets experience catastrophic events leading to their destruction. When these planets break up, large chunks from their cores and rocky surfaces are flung at thousands of miles per hour into the outer regions of space, forming what we have come to call asteroids. Asteroids residing from the cores of these planets contain large percentages of these technology metals that are necessary in today's technological world. Now, your initial thought may be, how many of these asteroids are there, and how many planets could have really broken up? Well, I want you to take a look at this picture. That is the asteroid belt between Mars and Jupiter, and it is a prime location for asteroids that contain these precious metals. In other words, there's an extremely large amount of potential resources just beyond our fingertips. Scientists have speculated that even a relatively small metallic asteroid, about a mile in diameter, could contain up to $20 trillion worth of industrial and precious metals. Many people have realized the immense benefits of having near infinite resources in such close proximity to Earth and are currently taking steps to obtain them. Companies such as Planetary Resources and Deep Space Industries are currently developing the infrastructure to identify, prospect, and obtain these resources. That's right, these companies are attempting to mine asteroids. Now, this isn't like the gold rush where anyone with a pan can just go out and mine gold out of a stream. Although this has the potential to be a $1 trillion industry, the barrier to entry is so immense in terms of capital and technology that it is only open to entrepreneurs who are already billionaires. So while you and I may not be able to make trillions of dollars off this venture, the influx of these metals in the global economy will significantly reduce the cost of producing technologies that utilize them. This in turn will reduce the cost of our $700 iPhones. In addition to reducing the cost of technology, there will be environmental benefits as a result of decreased mining activity here on Earth. The mining processes to obtain these materials are extremely taxing on the environment and currently produce thousands of tons of sludge, toxic gas, and even radioactive material every year. Finally, an asteroid venture will drive technological innovation, specifically innovation related to space exploration. The lucrative business potential of asteroid mining will cause investors to spend billions of dollars on technology designed to obtain these resources. With constant capital, this industry will be able to achieve more than, say, NASA, which has a limited government-allocated budget. Even with billions of dollars at their disposal, this will be a difficult and lengthy task to accomplish. You're probably wondering, how do companies plan to attempt this? Well, there are a few ideas. One ambitious plan is to capture an asteroid and bring it into orbit around Earth, where it can be mined. Unfortunately, we currently don't have the technology to accomplish this. Another idea, and one we're going to focus on, is to travel to a near-Earth asteroid. Now, a near-Earth asteroid is one which strays from the asteroid belt we talked about earlier and passes within close proximity of Earth, often closer than our own moon. Companies like Planetary Resources have developed a roadmap to create the infrastructure capable of mining these asteroids. While the roadmap is constantly evolving, here's what a typical mining operation may look like. The first step will be identifying which asteroids are economically cost-efficient to mine. This is done through a process known as telescopic spectroscopy. This process essentially measures the light reflected back from an asteroid and determines the surface composition based on the intensity of the returned light. Although technology metals are the end goal, most likely the first asteroid mined will be for water. Water can be split into hydrogen and oxygen through a process called electrolysis. These elements can then be used as fuel and oxidizer in a cryogenic liquid rocket engine. Rocket fuel is an attractive early resource for a few reasons. First, when a rocket is launched from the surface of the Earth, up to 90% of its mass can be the fuel necessary for it to escape Earth's gravitational pull. Having the capacity to synthesize rocket fuel in space would greatly increase the capability of missions in terms of distance. This will also serve as a transportation backbone for the mining industry, enabling future resource acquisition missions. So although we are a long way from bringing trillions of dollars worth of resources back to Earth, this is where it all begins. Establishing this infrastructure will pave the way for future mining operations and the eventual return of precious metals to Earth. Thank you. Earth elements. Just a large sniff.